Take everything you've ever seen, touched, breathed, or stood on. Now imagine that all of it, every single atom in your body, every star you've ever wished on, every grain of sand on every beach, was forged in less time than it takes to boil an egg. 60 seconds. That's the window. After the universe ignited, almost every meaningful piece of physics that built reality happened inside 1 minute. By the time a stopwatch hit 60, the universe had already chosen which particles would survive, what the rough recipe of matter would be, and laid the seed pattern that would grow into every galaxy. And here's what makes this stranger still: those 60 seconds weren't slow and stately. They were absurd. Time itself behaved differently. The first second alone contained more distinct cosmic eras than the next 13 billion years combined. So let's walk through them. Not as bullet points on a timeline, but as a story. Because what really happened in that first minute is one of the wildest narratives in science, and you, somehow, are the consequence of it. We start at zero. Or rather, we start as close to zero as physics still lets us speak honestly. At time equals 10 to the negative 43 seconds, a number so small your brain refuses to picture it, the laws we use to describe gravity and the laws we use to describe particles break down into nonsense. We don't yet have a working theory that handles both at once. So when scientists talk about the Big Bang, they aren't really talking about the moment of ignition. They're talking about what happened just after it, when physics started behaving in ways our equations can follow. By the time we reach 10 to the negative 36 seconds, that's a decimal point, 35 zeros, then a 1, something extraordinary takes over. We call it inflation. Imagine that the entire observable universe, all hundreds of billions of galaxies that we can see today, is squeezed into a region smaller than a single proton. Then, in a flash so brief it makes a lightning strike look glacial, that microscopic region doubles in size. Then doubles again. And again. And again. Roughly 60 doublings, in a window of time so small you'd need 100 quintillion of them to add up to a single tick of a clock. By the time inflation ends, around 10 to the negative 32 seconds, the universe has stretched from quantum scale to roughly the size of a beach ball. That's a magnification of about a billion times. Nothing has ever moved that fast, because nothing was moving. Space itself was expanding. The galaxies of the future weren't running away from each other yet, the stage beneath them was being unrolled at impossible speed. And the strangest part isn't even the speed. It's what inflation left behind. During those tiny fractions of a second, quantum fluctuations, random jitters in the fabric of space, got blown up to cosmic proportions. Frozen into the geometry of the universe. Those frozen ripples are why galaxies exist at all. Without them, matter would have spread out in a perfectly smooth fog with nothing dense enough to collapse into a star. The great cosmic web of galaxies we see today is the fossilized echo of quantum noise from that first trillionth of a second. So inflation ends, the universe is the size of a small fruit, and the temperature is something like 10 to the 27th degrees Kelvin. To put that in perspective, the core of the Sun is around 15 million degrees. We're talking about a number so hot that the word hot stops meaning anything useful. At that temperature, every particle that physics permits to exist is bubbling in and out of being simultaneously. A churning, screaming soup of fundamental matter, quarks, gluons, electrons, neutrinos, their antimatter twins, and energetic light all sloshed together with no distinctions yet. This is where the universe makes its first major decision. And it's a decision that, frankly, we still don't fully understand. For every billion antimatter particles in that primordial soup, there were 1,000,000,001 matter particles. Just one extra. Why? We don't know. The leading theories involve subtle asymmetries in the laws of physics. Some particles decay slightly differently than their mirror twins. But the consequences are everything. As the universe expanded and cooled across the first millionth of a second, those billion pairs of matter and antimatter found each other, annihilated, and vanished into pure radiation. Only the 1 in a billion surplus survived. Everything you are made of is that surplus. Every atom in your body is a leftover from a cosmic massacre. If the count had been exact, 1 billion matter, 1 billion antimatter, there would be no stars. No planets. No us. Just a universe of light, expanding into emptiness forever. By around 1 microsecond after the bang, the universe has cooled enough, only a few trillion degrees now, for the quarks to stop bouncing around as free particles. They lock together in threes, forming the first protons and neutrons. The matter we recognize starts crystallizing out of the chaos. If you could stand outside this moment and watch, you wouldn't see anything. The universe is still a blinding plasma, opaque, glowing white-hot like the inside of a star, but denser. It's not a place. It's a fire that fills everything. A second has passed. In the next minute, something remarkable happens. The universe cools from billions of degrees down to about 1 billion. Protons and neutrons start bumping into each other and, occasionally, sticking. This is the era of Big Bang nucleosynthesis, the cosmic kitchen where the first chemical elements are baked. 2 protons and 2 neutrons fuse into helium. A few stragglers form deuterium and lithium. But the window is brutally short. By 20 minutes, the universe has cooled too much for further fusion. The cooking stops. When the dust settles, the universe is roughly 75% hydrogen, 25% helium, and a trace whisper of lithium. That's it. Every other element you know, the carbon in your cells, the oxygen you breathe, the iron in your blood, the gold in any ring on your finger, none of it exists yet. Those will all have to wait hundreds of millions of years to be forged inside the cores of dying stars and the shockwaves of supernovae. But the raw inventory is set. The cosmic pantry has been stocked. And the universe will spend the next 13.8 billion years rearranging that hydrogen and helium into everything else. Now here's where intuition fights back. When you hear Big Bang, you probably picture an explosion. A flash, a shockwave, debris flying outward into empty space. Forget all of that. The Big Bang wasn't an explosion in space. It was an expansion of space. There was no outside. There was no center. Every point in the universe, including the patch of space your kitchen now occupies, was right there in the dense fire of the first second. The universe didn't blow up into a pre-existing room. The room itself inflated, carrying every future galaxy along with it. Which means when you look at the night sky and see distant galaxies racing away from us, they aren't fleeing from some original explosion site. The space between us and them is stretching. It's still stretching. Right now, as you breathe, the universe is still doing the thing it started doing in those first seconds, quietly, gently, but relentlessly growing. The other piece that breaks intuition is the speed. Within that first second, the universe ran through more transformations than have happened in the entire span of human history. Inflation, particle formation, matter winning out over antimatter, the strong force locking quarks into protons. By the time you'd finished saying the word bang, the architecture of physical reality was already drawn. Everything since then has been slow weather on a stage that was built in those opening moments. What scientists find genuinely fascinating isn't the spectacle. It's the fingerprints. We can't go back and watch that first minute happen. But the universe left receipts. The cosmic microwave background, that faint hiss of radiation filling the sky, is a photograph of the universe at 380,000 years old, and its tiny temperature variations match precisely the patterns inflation predicted. The ratio of hydrogen to helium we measure across the cosmos today matches the nucleosynthesis calculations from that first 3-minute window down to the decimal. A theory written on chalkboards predicted what we'd see, and the sky agreed. So when you next pour a glass of water, consider this. The hydrogen in those molecules is original. Not original to Earth, original to the universe. Forged within the first 3 minutes after time began. It has been doing nothing but waiting, drifting through clouds, gathering into stars, being scattered by supernovae, and finally pooling on a small blue planet, for 13.8 billion years, just to end up in your hand. The helium in the air you breathe out, same story. You are walking around inside a body whose lightest atoms predate every star, every planet, every solid object in existence. 60 seconds. That's all it took to write the opening sentence of every story the universe would ever tell. The stars came later. The galaxies came later. The chemistry of life came much, much later. But the rules, the inventory, the seed pattern of where matter would clump and where it wouldn't, all of it was decided before the first minute ended. Look at the back of your hand. Every proton in every cell was already there, already finished, while the universe was still less than a minute old. You are wearing matter that is older than time as anything else in existence knows it. And it has been waiting, patient and unchanged, for the slow universe to finally arrange it into